Hey, we're working a quadratic word problem here. You may not know what's quadratic until after you read it and get working, but it says a rectangular fence is built next to a barn so that fence is only needed on 3 sides. So let me kind of get a little picture out of the way. So basically there is a barn here and we're going to build a rectangular fence off of it so that we only have to build 3 sides because the barn will be the 4th side. It says you have 160 feet of fence to work with. What are the dimensions that will produce the maximum area of the garden? So here is that maximum question, and we're also talking about area, which is a multiplication. Remember, area is length times width. So if we have a length and a width and we multiply them together, if both of those were variables, we'd have a quadratic. So let's see. Once again, let's just kind of throw some things out here. Here's an L, here's a W, but there's 2 W's but only 1 L. And since we have 160 feet of fence, we can make a similar equation about the way we're going to use the fence would be 160 equals L plus 2W. So those 3 sides will use up our 160 feet of fence. So instead of using both L and W in our quadratic, which would not be good, we can get L by itself pretty easily. It would be L equals 160 minus 2W. So when we start talking about an area function, we can make it in terms of W. So the length is 160 minus 2W, and then it'll be times W. So if we distribute and move things around, we'll have negative 2W squared plus 160W. And there's our quadratic in the right form. So if we're going to talk about maximum, we can talk about the vertex, which in our case would be W equals negative B over 2A. Negative B will be negative 160. 2 times A will be negative 4, so negative 160 divided by negative 4, I believe, is positive 40. So the width will be 40 feet, and that'll be on both sides. And if we say we used 40 feet on the 2 sides, and then we have the 1 side left over, out of the 160 feet, we used 80, so there's 80 left. So the dimensions here are 40 feet by 80 feet. Okay, so basically we found the X, or the W in this case, part of the vertex, and then we plugged the 40 in, and that led us to, will lead us when we want to find the maximum area to whatever we get. In this case, it'll be basically 40 times 80, but if we plug it into the formula, be negative 2 times 40 squared plus 160 times 40. But once again, that's just 40 times 80. In the end, this will be 3,200 feet squared. That would be the max area. So that max area will be 3,200 feet squared. Okay. The hard part is building the quadratic to work with and making sure you understand the problem.